So, these are clearly not Gina Wilson notes. You can tell because the font is basic. Comic Sans, maybe? All right. The Pythagorean theorem is... What's the Pythagorean theorem?
Thanks to our book. Does anyone want building a
I'm pretty sure we are too chatty today. It is borderline disrespectful. All right, so we're gonna bring it down a notch. I'm pretty sure they expected us to write it out in words, but I did not. So in other words, the same words: a squared plus b squared equals c squared, but with a smiley face. There we go. Nice. Does anybody know what a Pythagorean triple is? Have you heard of that before? No? Yes. That like fit that. So 3, 4, 5 is an example of one Pythagorean triple. Okay, that's one of them. Anyone know what another one is? No? There's one that does have 8 in it. 2, 4, 6, 8 is not a Pythagorean triple. So they're ones that make it true. So like one of the triangles that works with the Pythagorean theorem is 3, 4, 5. So that's considered to be a Pythagorean triple. Another one is, I think it's 5, 12, 13. I think. Let's double check that. I think it's 5 squared plus 12 squared equals 13. Something is a Pythagorean triple if it makes that true. So 5 squared plus 12 squared, oops. Yep, that's a Pythagorean triple. So 5, 12, 13 is another one. 6, 8, 10 is another version of 3, 4, 5. So once you know a Pythagorean triple, you can just take all the sides and multiply them by a constant, and then that will give you another one. So if we took this one and then that gives us, it's twice as big, and it gives us another Pythagorean triple. So if you look, if you take your phone out, if you Google Pythagorean triples, you'll find a bunch of them. Anybody want to do that and tell us some more of the Pythagorean triples? And you might recognize some of them. They'll be right triangles that you've seen before. Have you guys seen a 5, 12, 13 triangle before? Does that sound familiar maybe? Okay. Anybody else looking it up? Alex is looking it up. We got Rebecca, Mason. What is another one? 9, 12, 15. 15, 20, 25. So this is another version of this, just times 5. What's another one? Okay. So those are all Pythagorean triples. So they're just side links of right triangles that work with the Pythagorean theorem. Okay, so in here, go ahead and draw a right triangle. And then here's what we're going to do. We're going to solve it using the Pythagorean Theorem. And the Pythagorean Theorem is not new to you guys, right? This is not brand new. Okay, we've done this before. So if we have this, the only thing you have to remember is that the right angle always points to the hypotenuse, and the hypotenuse is always the side that is C. So in this case, the X would be the side that we're going to label as C, the A and the B, hypotenuse. If we were to do a math spelling test, that would be on it.
No, I don't think that's a little
hypotenuse. That's how you spell it. Hypotenuse. Hypotenuse. So this side is always C. Other than that, the other two are just A and B, and it doesn't matter which is which. So we've got 7 squared plus 10 squared equals x squared. What's 7 squared? What's 10 squared? Okay. What's 49 plus 100? Okay. So we get x equals, now we're not going to kill a baby horsey, we would say plus or minus square root 149. And then because this is the side length of a triangle, we would say, okay, x is just the positive version. We're going to ignore the negative version. We're going to use the positive version. So it is the positive version of the square root of 149. Can that be simplified? Maybe? No? Doesn't divide by 2 or 3, so that means, and doesn't divide by 5. Divide by 7? Nope. So probably not. Okay, so this is the simplest radical form. Okay, so off to the side over here, when you leave it in simplest radical form, this is called the exact answer. This is called the exact answer. And we've talked about this before, right? This is not news. Okay. Now, for this particular worksheet, this is not how I've done it. I usually say to the thousandth, but the creator of this particular set of notes in this particular worksheet said to round to the nearest tenth, not thousandth. Does anyone know how many decimals the nearest tenth is? It's just one. So square root 149 is 12.2. So 12.2. And this is our approximate answer.
Did you ever find out what your foot was broken?
Mm-hmm. Mm-hmm.
Broken one?
It is, I think it's like 2 little breaks, but it's a good type of broken. A lot of times when people have a broken foot, they have to have surgery and have pins put in it because of the way your foot, like the bone, there's lots of bones in your foot. But I had it broken in a good spot where it didn't need pins and where it heals easily. So yeah, I looked out. All right. The converse of the Pythagorean theorem, I'm pretty sure the converse is where you can use the Pythagorean theorem to prove that a right triangle is in fact a right triangle, but let's Google it because I'm not positive. So somebody look up the converse of the Pythagorean theorem for me and tell me what it says. Converse of the Pythagorean Theorem.
Third side of the triangle is equivalent to the sum of the two shorter sides, then it must be a right triangle.
Yeah, okay. So the converse of the Pythagorean theorem just says if c squared equals a squared plus b squared, then if c squared equals a squared plus b squared, then the triangle is a right triangle. Ms. Rice, when are we ever going to use this in the real world? Oh my gosh, you can actually use this one. You can make sure in construction that your corners are square by doing this. I used the Pythagorean theorem to make sure that I had the ends of my little sign there, that I had them even. No, I'm not joking. I did it so I could figure out how long my string should be, and then to make sure that I could place my corners so that it would look right when I hung it in a corner, so that it wouldn't look wonky and off-centered. You would eyeball it, and everybody would be able to look at it, and they'd be like, I don't know how, but it's off somehow, and I use math. No, it's just the lighting. It's the lighting. It's a shadow. All right. So if we wanted to know if something was a triangle, we would just, if we wanted to know if it was a right triangle, we'd just do the Pythagorean theorem, and that's how we would double check. So I'm going to go ahead and draw. They're going to look like right triangles, but we're going to figure out if they are actually right triangles. Okay? Okay? Hold on, actually. So I did not draw a right or a right angle in there. So they look like right triangles, but we're going to double check to see if they are. Sound good? Okay. So what we're going to do is we're going to say 25 squared equals 8 squared plus 23 squared. And we're going to check to see if that's true. Okay? 25 squared equals 8 squared plus 23 squared. We're going to check to see if that's true. If it is true, then it's a right triangle. If it's not true, then it's not. Okay? Alrighty. Alright, so 25 squared is what? 625. Okay. 8 squared is what? 23 squared is... Okay. Okay, is this true? No, so what is our conclusion? No. Okay. All right, let's try the other one. You just try no. Because it just says, are the following right triangles? So those are yes or no answers. Either yes it is or no it's not. So for this one, we got 30 squared equals 24 squared plus 18 squared. And what's your conclusion? Yes. Can you guys tell which Pythagorean triple this is? Is it a brand new one, or is it one of the ones that we already wrote down?
Nine, 12, I'm kidding. Wait, no, it's 9, 12, 15.
No, it's 9, 8, it's 9, 8, 12.
Wait, isn't it 9, 12, 15? No, yeah,
Wait,
9, 12,
if it's a 6, 8, and 10, what is it actually?
9, 12.
6, 8, 10. 6, 8, 10.
It's actually a 3, 4, 5. 6, 8, 10, and 3, 4, 5 are the same thing. So it's actually a 3, 4, 5. So 3 times 6, 4 times 6, 5 times 6. So I just took a 3, 4, 5, and I multiplied all the sides by 6. That's how I got this triangle. Does that make sense? Okay, I'm going to go back and add a 90-degree angle in there because it's true. Alrighty, so the offshoots, these are conclusions of the converse of the Pythagorean theorem. So here's what we learned then. If c squared is bigger than a squared plus b squared, then the triangle is obtuse. So then the angle that would have been 90 is actually bigger than 90. Okay? So we're going to say this angle right here is obtuse. So that's what would have been the 90-degree angle actually ends up being bigger than 90. If c squared is less than a squared plus b squared, then the angle that would have been 90 ends up being acute. Ends up being acute angle. Get it? Cute little angle? No? Okay. So let's look back. Let's look back at the one that we did over here. Would that angle have been more or less than 90? Obtuse angle, so this angle would have been more than 90. Okay. So we're going to do the same thing again, but with 2 more triangles. And this time we're going to say whether the triangle is an obtuse triangle, an acute triangle, or a right triangle based on the numbers that we're working with. Okay? So for this one, we're going to do and then for this one, okay, so let's go ahead and do this one first. What should we do to figure out if the triangle is acute, obtuse, or right? Yep, just what we did on the other side. So we're going to do 13 squared equals 4 squared plus 10 squared. Okay. So 13 squared So what is our conclusion? Obtuse. It is obtuse because 169 is bigger than 116. So this angle is obtuse. Okay. Shoop. There's the other one. We didn't do this one. That's funny.
I already wrote 30, so we like keep 30.
Yeah, let's keep 30.
Oh, did you write in pen? Yeah. It's called a pencil. Then why would you do math in a pen? That's called. Hold on. No, what's egotistical? Ego's boosted if I do math in a pen. Yeah. You need to be humble. I hope you get the next one wrong. I hope so too. Thank you. Let's be humble.
Okay.
We talked about humble. You know, everyone needs to be humble.
Oh, it is, yeah.
At least when I get those erasable. I bought those were like the big thing. Yeah. Like everyone was like, "Oh my gosh, you have erasable pens!" And you have the highlighters too. They were so expensive. Yeah. They were like $40 for a pen. They didn't erase that well. I know they erased sharpener. I haven't got it yet. Yeah, not that.
Ooh, so what's our conclusion here? It's acute. Okay. It says Mr. Kelly is 120 feet directly north of Mr. Breast. Not breast. Breast. Don't giggle. Okay. These names, these guys, these names are actually the names of the guys who make these worksheets, and they call themselves the Algebros.
Oh, no. No.
Did you see the freaking
All right. So directly 125 feet directly north of Mr. B is Mr. K. Directly to the east of Mr. K, 500 feet away, is Darth Vader.
Wait, is it bad if you flip the triangle ever the other way?
Yes.
I mean, it's not accurate. Because this is north and this is east.
North is up, so I just did the B on the bottom and went up to I'm not good at geography.
North,
no, we're doing directions.
East. Okay, I'm sorry. I'm just wondering how you could draw it differently when they clearly said north and then they said east.
Kelly is still north.
But then you drew west.
I drew it to the best of my abilities.
Yeah.
Alex is being humble. I don't need humble. You guys are.
Okay, we can already tell just by drawing the picture who is closer to catching Darth Vader. It's clearly, yeah, it's Mr. Kelly because he is the leg of the triangle, not the hypotenuse. The hypotenuse is the longest side. Okay, but we do have to do some math because they say how much closer, and so we actually have to know how long the hypotenuse is to be able to answer that question. So let's go ahead and do this problem. So we're going to do 500 squared plus 125 squared equals x squared. How many answers do we get for x? 2. We get plus minus. I'm going to round it to 1 decimal place to make this easier on myself. And then which answer do we want to use? The positive or the negative one? The positive one. Okay. Because we are showing the person who's grading our paper that we understand you have to do both. Mathematically speaking, you have to do both and that one of them is extraneous. Because we're not trying to kill baby horsies. I mean, maybe you guys are trying to kill baby horsies, I'm not. All right, how much closer is Mr. Kelly to catching Darth Vader? Yeah, I use a bunch of their stuff in my calculus class, and they always use their names. I use my name too, but I use it more in a more cheesy way, where I'll put rice in every single problem. I'll be like Rice Mountain, Rice High School, Rice whatever, and I'll so instead of being a person, I'll just be everything.
All knowing everything.
Yeah.
Miss Rice.
We're going to Riceville. Captain Rice is flying the rice plane. Yeah. Just in case you were wondering if I was serious or not, you can tell I'm really being sarcastic about it. It's a good time. It is. I was reading a book this weekend, and my first and last name was the name of a character in the book. It was weird. It was a teenager. She was 14. I was like, well, that's not me, but still. Yeah, I was reading it, and it was like, Katie Rice, blah, 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 and I was like, what? That's me! No. She had just started, well, I don't know yet, because it's the beginning of her part of the story, but she had just started becoming someone who was training to kill people, so that was cool. So yeah, I'm vicious and violent, and I'm good with knives. I was walking, sir. All right. We're gonna put an X through these because I'm tired of coming up with problems on the fly.
Why did they do the problem?
Okay, so these, you know how, you don't know this because you're not in my math 3. They do flipped videos just like I do. So these notes are supposed to go along with the video where they just go over the notes. So in theory, so basically these, I'm plagiarizing right now. I mean, in the teacher world, plagiarism is normal. This type of plagiarism is normal, where it's like if you post, the idea is if you post your notes where other teachers can get to it, don't reinvent the wheel, just borrow and then use it. Yes. The university, I went to a teaching university, like most of the people who went to my university were going to become teachers.
What university?
It was Concordia University in Portland, Oregon. They could not come up with a school-wide policy on plagiarism because the teaching side of the school did not agree with their definition of plagiarism. They were like, that's just not reinventing the wheel. That's just using your resources. And then and then everybody else was like, that's literally plagiarism. And we were like, no, it's not. Teachers all the time borrow resources. If you don't want people to borrow it, you password protect it. That's literally how it works in the teaching profession, is if you put your stuff online and it's not password protected, it is free game. People will print it, they will use it. Yes. It's just how it works, yeah. So if I put a worksheet up and I don't password protect it, I fully expect another teacher to print that worksheet and use it in their classroom. Fully expect it. There is not another set of notes. Yeah, no, these are practice problems. So you're doing these and you're doing the other, and it's no, that's fine. Because you guys aren't really learning this for the first time. All right, let's go ahead and start working on the practice problems. I think you guys will be good because this was a pretty simple, straightforward lesson. So, any questions before we just go ahead and get started? Good. I support it. Fully support it. All right. So I'm going to start working on the answer key. I'll get that on the back wall as soon as I can. This is the appropriate way to show your work, because when we are solving this equation, there are two solutions to this equation, but for the context of the problem, only one of those solutions works. Does that make sense? So I should see that you got two solutions to the equation, but then I should see that you used your brain and went, oop, the answer's positive 13. Okay? There's a lot of room for killing horsies today. Let's not kill any. Yeah, I know you are. I'm going to mark down how many horsies you kill. I'm going to mark down how many horsies. Yeah, let's not, because I'm going to post the answers and I need to see your work. All right, sir. Marvelous. The only place, listen carefully, the only place I will accept missing work is if the problem is a Pythagorean triple. Okay, so like number 2, if you are like, that's a Pythagorean triple, that's a 6, 8, 10 triangle, and you just want to put 10 there, and then you want to write for your explanation Pythagorean triple, that's fine. Does that make sense? Okay, so Pythagorean triples, that's okay. Do not try to tell me that number 4 is a Pythagorean triple. It is not. So I need to see work for problems like number 4, but a problem like number 2, if you want to say for your work it's a Pythagorean triple, that's okay. Does that make sense?